It's not the best timing since you're sort of preoccupied about this stupid exam that you have tomorrow, but just the way that the courses work out, we have to start a new topic that's it's not going to be on the midterm, but I think it's an interesting topic, and so for the next little while we'll be working with PyGame. So what's PyGame? It's an extension or a module for a collection of modules for Python that was designed to help making games easier. So easier, but not easy. In fact, PyGame is sort of a very thin layer on top of something called the SDL, which was an older gaming library for gaming in other languages. So it's going to take us a little bit of time to get up to speed. Not much. We'll do some things today. But to give you an idea of, let's say, how quickly it's possible to get up to speed, I decided last week, last Wednesday or so, that maybe we should consider using PyGame in this course. I had never used it before. And really the only reason that I decided to was because a different instructor in our department got the tech staff to install PyGame on the lab machines. I was too lazy to do that myself, so I wasn't going to bother. But she did it, and so I thought maybe I'll take a look at it. So on Sunday, so that's whatever, 5 days ago, I decided to start looking at it. And really the best way to do these things is to program a couple of games, or try and see what it's like to program a couple of games to see if it's something that I could ask you guys to do. So on Sunday, not having known anything about PyGame, I managed to finish one game. Here it is. It's called 3SAT. Has a soundtrack, really funky sounding. So it's a game based on a famous computer science problem of satisfying circuits. You have these little plugs at the bottom that switch a circuit from being on to off, and what you need is for each of these little hat-shaped things, you need at least one of the wires into it being on. And these little triangles here, they're called inverters. They change the state of a circuit from being on to off or off to on. So these things are really, you're trying to satisfy some logic formula. So here, for example, everything is already satisfied except for this red one, and if I click this, it gets satisfied. Here, everything's already satisfied except this one. If I click this, it doesn't quite work because these two wires here, which lead to that, this becomes unsatisfied. So there's a problem there, so I have to try some other options. Maybe that one will do it. Nope. Maybe that one. Nope. Maybe that one. Nope. Got it with a second to spare. And the game has, all these elements. There's timing, there's a score, there is difficulty in that the times get shorter and the sizes of the circuits increases. And in fact, there's another sort of difficulty, which is the circuits get harder to solve in some sense. So there's a measure of how easy it is to solve a circuit. One of the measures is how many of the different states the plugs can be in that actually give you a solution. And this keeps finding circuits with fewer and fewer solutions. So eventually you get up to 8 plugs, so there's 256 possible combinations, and only one of them actually works, and you have 20 seconds to figure out which one. So just trying them all doesn't work. But if you're good at binary arithmetic, at least for the small ones, you can just try them all very quickly. Anyway, so that was my first attempt at a game. That was my Sunday attempt at a game, and it's a little cheesy. The music makes it especially cheesy. I don't know if you guys can hear it. So that's my first attempt. And these are already online in my GitHub repository. So my second attempt, I thought maybe I'll actually spend some time thinking about what I want to accomplish with my game. And so it's called Alpha Pop. So there I actually spent the better part of a couple of days thinking about, well, okay, so that other game was just sort of a quick test. I didn't think too much about what it should do. And this one I actually wanted to accomplish something. And so I have a daughter who's 3 years old, and when she was very young, about 18 months or so, she learned how to recognize letters of the alphabet in the bathtub. So we had these little foam letters. They're super puffy, and by showing her letters and associating them with friends of hers or objects that she knows, she was able to recognize those. So I thought, great, she knows her alphabet at 18 months. That's fantastic. And then I ignored it for the next year and a half. And so recently I tried testing her again on this and discovered that she couldn't recognize letters, so I thought she'd forgotten it. But that's not true. She hadn't forgotten it, because if I went and got those letters from the bathtub, those big puffy ones, she can still recognize those. So what she has problems with is just changes in fonts, basically, and changes in case, of course, because all those letters were uppercase. So I thought about whether it's possible to make a game that can help her with this. And then, you think, well, what is she like? What does she do? One thing I've noticed is she's obsessed with anything that has a screen, so computers, TVs. So video games seems like a good thing there. She also likes to blow bubbles, and she really likes to see pictures of herself. So so I decided to put all those things in there, and I wanted it in with something that she could play with. So one of the nice things about PyGame is that there's a subset of it, so not the entire library, not the entire module, but a good chunk of it is actually ported to Android. So if you write a game in PyGame using PyGame and you don't use too many advanced features, then it's actually not much effort at all to get it running on an Android device. So I'll show you the game.
Point to the letter Y.
So different letters, different fonts. That's a picture of my daughter on the beach.
Y. Yes, you did it.
I managed to...
Where's the letter O? O. There it is.
Okay.
Find the letter S. S. Super. Where is the letter D?
Okay. So you
Excellent.
get the idea. And
Show me the letter Q.
and so I polished this. This took a little longer because there's some voice recording and there's some artwork. This is not a game with timing elements, so she can put it down and walk away from it. Yep. Where you would say what? Yep. Looks like this. So it's just an annoying thing, and supposedly you can make these Android devices vibrate, but I was unable to get that working. But just to show you, there's actually a beautiful version of this. So there's a beautiful display on that device, much nicer than this thing, that does it and makes it into a touch game. Okay, so so all that to say, this will be a little confusing for you guys at first, but it really doesn't take long to get up and running and make something useful. Yep. Why not just build it from scratch? Because any game, graphical game, will have to have an interface into the windowing system. And the portable interface into the windowing system is tkinter, and it's not a couple of things. It's not very general, and it's also not very high performance. Whereas SDL or PyGame, which is an interface into SDL, is just better suited for making games. So I could have taught you this other thing, which is what we did last year. Students weren't terribly excited by that last year, so we're trying something different this year. But tkinter is the, if you're doing something like making applications with lots of buttons and drop-down menus and stuff like that, tkinter is what you'd rather use. This is really optimized for games and animation. Okay. So all of that is my my little motivational speech to show you how easy this is. Maybe it'll take you guys a little bit longer than a week to get up to speed, but we have we'll do sort of like we did at the beginning of the semester, a couple of warm-up assignments leading up to you making a game of your own design. And so now you know that 2 to 3 weeks from now, you'll be making your own game. It's time to do the creative parts of that, thinking about what you want it to do, maybe making a feature list, maybe organizing that feature list in terms of order of importance, because it's very easy to come up with a feature list which you can't implement even in a year. So think small and work your way up. And you know, in 3 weeks you'll get to show this off, and we'll let you showcase your games on the course forums, for example, if you choose to. Okay, so you all excited? Yeah, good. Okay. So enough beeps and clicks and stuff like that. Now it's time to go back and look at some source code. Yes, good work. At some point it starts showing lowercase letters as well. Okay, so here's a super simple game. In fact, it's not really a game. Let's play it. So there it is. Yeah, so the object of the game is to close this window, I guess. That's all it does. And to close it, you click on this little X over here and it disappears. So I just won the game. But let's see how, what we went through to get to there. So one thing is we have to import some stuff, sys and PyGame. Anything wrong with this code up here? Anybody remember from last class? Guido would be very unhappy. It's equivalent code, but this is better for Guido. And the ordering is not his favorite either. Something like that. But that doesn't make a difference. Okay, so it helps to use object-oriented programming for these things. So this game is encapsulated in a class. The class is called MyGame. And if you look at the last line of this code is to create an instance of MyGame. So when you create an instance of MyGame, it calls init on the init method of the MyGame class. And here's the first thing you need to do if you're going to make any game in PyGame is initialize it. Then you decide how big you want your window to be. And I think for the first little while, at least for the first assignment, we'll fix the window size for you because dealing with variable size windows can be a pain. So we'll fix that at something reasonable, 640 by 480 in this case. Maybe we can go a little bit bigger, 800 by 600. And then you tell PyGame, in particular, you tell PyGame's display to set the mode to the width that you specified. Thanks. Okay. So far, we've just set up a display, and it's supposed to be 640 by 480. Here we save a color that we're going to use later. And, well, PyGame, like most graphical programming environments, spends most of its time sitting around waiting for something to happen. So if you think about this computer, it spends most of its time doing nothing, right? This computer on my desk here, right now it's just sitting there waiting for me to push a key or move the mouse or something so it can do something in response. And so while it's doing that, it's just called some operating system level thing or window managing system level thing, which just says wait for something to happen. So that's what PyGame games do. They go into an event loop. So that's what we do here. We call this event loop. Event loops last forever or until you break them some other way. And we just sit there and say, wait for an event. So wait for something to happen. And here there's two kinds of events that we're waiting for. We're waiting for the user to ask us to quit, or we're waiting for an event called refresh. Okay, so we can print this out, and I could even say, let's just change that for a second. So let's look at these. So normally if you have a tight loop like this and you put a print statement inside such a loop, what you end up is with a stream of text, right? Just super fast going by. If we do that, you don't actually get that much happening. So it's just sitting there. Every 1 second there's an event that happens. That's that refresh event that's telling it should display itself. But mostly nothing happens unless I, for example, run the mouse over the screen. Then a whole bunch of events come pouring in. And if I push a mouse button, I get a mouse button down event. And if I let go of the mouse button, I get a mouse button up event. Down, up, and so on. If I push a key, I get a key down event. Just one to say the key went down, and when I let it go, I get another event to say that it came back up. Okay. So in this thing, all of those events are discarded. There's only, we only check for two things: the quit event, which is the event that you get sent if the user clicks the X on the corner of the window. So the windowing system sends this PyGame quit event, and then there's this refresh event. Where does this refresh event come from? It comes from up here, where we set a timer to remind us to do something. And we said every this many milliseconds, send one of these refresh events. So that's what timers do. They set little reminders to do something. And an important thing about timers is when you set them, they repeat automatically. So you don't have to keep resetting the timer. It's like a little bit like an alarm clock. It'll keep going off at the same time every day without you having to turn it back on all the time. Or like some alarm clocks anyway. So in this case, we set this to go off every 1,000 divided by self.fps milliseconds. So 1,000 milliseconds is 1 second. And so this self.fps is supposed to represent the number of frames per second we want to update the display. So in this case, it's 1, but that was just for illustration. A 1 frame per second game is not a really nice looking game. That's horrible. There's no reason we can't go 30 frames per second. The only reason that I changed that is because if I'm going to print these events, I don't want to print 30 of them in a second. I wanted you to see what some of the other events look like. Okay. So this does two things now. Either we get a quit event when the user clicks the close button, or we get this refresh event every, 30 times per second. So every 33.3 and a third milliseconds. And on these refresh events, we call this method draw. And what does draw do? It takes the screen and fills it with this background color that we defined earlier. Okay, so it does that, and then it says something. It says display flip. So PyGame and many graphical things use a technique called double buffering, and the way to think of that is like this sheet of paper here. So imagine this was a whiteboard, and I was trying to teach you without any projectors or anything. Then I'm holding, and it's a two-sided whiteboard. So I'm holding this up, and you're looking at this side of this whiteboard. You see something, and while you're looking at that, I'm making notes on the back of it. So this is the two sides of the double buffer. I'm making notes on the back of it. I'm drawing stuff on the back of this. And I don't want you to see things as I'm drawing them, because that takes some of the magic away. Right? If you see a game where the characters are appearing somehow being drawn and you see what's happening, it looks weird. And so I'll just hold this one frame up until I'm ready, until my picture is completely finished on this side, and then I flip it and show it to you. So that's exactly what happens here. Here I'll do, in these draw functions, I'll do all the work of drawing whatever it is I need to draw. The user doesn't see any of that until I call flip, and then they see everything that I've drawn. Okay. So I have this canvas that is, in this case, 640 pixels wide by 480 pixels high. The only thing that this thing does is fill it with black, and then once it's all filled with black, it flips it over and shows it to the user. And the reason that games work that way, or animation in general works that way, is this flipping over operation is very fast. It's something that can be done very quickly. In fact, it's something that can be done in the time in between your screen two refreshes of your computer screen. So your computer screen refreshes something like 60 times a second, and so that means it's not constantly displaying an image, but it's actually every 60 times a second it's showing you an image, and in between those 2/60ths of a second is when the flip happens. So you'll never see half an image or partially drawn image. You'll just see what was there before, and then the next time what's there now. So there's this flip that happens. And this is a source of consternation sometimes, because you'll say there's some complicated scene I want to draw. You'll draw part of the scene, you'll code up the part of the scene and you'll test it, and you'll say, okay, I want to draw something more. All right, so I want to add some stuff to this scene, and then you start writing code here, where you do something like, say, PyGame .draw .circle. I forget what you're supposed to specify here. Maybe the position and the color and so on. Whatever, some parameters that define a circle. And now you run your code again, and nothing's changed. And, well, that's because you put your code in the wrong place. So if you think about what happens, the screen gets filled black here, then it gets flipped, and now you're drawing on the back side of the screen. The next time you draw, you're still drawing on the back side of the screen, so you erase your circle that you drew, make it black again, and then it gets flipped, so all the user ever sees is black stuff. They never see this circle that you drew. So I made that mistake a couple of times. In fact, so much so that I prefer to let the flip happen up here. Okay, so seems like a lot for just a black window, right? It's a lot to go through. So any questions about that so far? This is foundational stuff, so be sure to ask if you need to. Yeah.
So I noticed that when you had frames per second at 1,
Yeah.
when you were printing out the events, it was showing a lot of events even though FPS was still at 1.
It was showing a lot of. Well, if we just quickly look at that again. Print event. It wasn't showing much, so a bunch of events happen, and now, right, we're seeing about 1 event per second now. 1 event, and that's the draw event. So you're seeing it happen once a second, and as soon as you move a mouse over this window, you get an event constantly. So it's every time the mouse moves, which is, if you're dragging the mouse, it's constantly moving. So you get tons and tons of events there, but step away from the keyboard and you're back to this 1 event per second.
So when you're actually making the game, basically you want to make sure that you're making sure that the events are inside where you set a single frame instead of outside that. Because otherwise the events that you're inputting in will go outside the frame per second.
Well, let's see. That's okay. For events to happen between frames is okay. So for example, let's try and do something here. Let's make an event that actually accomplishes something. So I want to go back to 30 frames a second. And so what other kind of events? We saw that there's these key down events. So if event.type equals key down, so that happens when somebody pushes on a key. Then maybe we can change the background color. Right. So self.bg color. It was black before, so black is 0, 0, 0. If we want to make it red, well, so do any of you guys, have you ever worked with RGB colors before? Yeah, okay, so colors are, in the RGB color space, are specified as how red they are, how green they are, and how blue they are. So black is not red at all, it's not green at all, and it's not blue at all. It's just black. White is completely red, completely blue, and completely green. So if we wanted something simple, like pure red, we'd specify its red component is complete 255, and its blue and green components are nil. Okay. So we just do that. We just change this background color variable. So we don't redraw or anything at this point, but we know that we're redrawing every 30 times a second. So the fact that we change this variable is used in the draw method, and so it'll get reflected at the next refresh. So let's test that out. So hopefully when I press a key, the screen turns red. Okay.
So, I guess it worked my question back. My question was, let's say you have like Boolean checking to see if it's been red or if it's been black.
Yeah.
Is it possible to, behind the scenes, within each frame, press the button so fast that it'll actually change from black to red to black again, and you won't even see what happens?
Yeah, if someone can press the button, twice within within a span of 1/30th of a second, then they can sneak it through without you getting anything. But typically what happens is, I mean, this is a sort of a weird thing, this changing color, and we could try this by setting frames per second to 1, and I could, you know, sneak in a button press. In this case, it just goes from black to red and never back. But if it switched back and forth, I could do that. But you know, think about games, and typically, what happens is a button press really represents some action in the game. So it's not really about drawing that matters, it's about the action happening. So maybe the button press represents shooting a bullet, or you know, pulling the trigger on a gun, or moving a step to the left, or whatever. And so there's not really a problem. If it represents shooting a bullet, the next time you start drawing, that bullet's going to be taking off, even though this happened. And if it's, you know, taking a step to the left, so if you take a step to the left and a step to the right so fast that no one could see it, then so what? That doesn't hurt anything either. Okay, so we can go back to black on the key up event. So it's black, I press a key, it's red, I let go of the key, it turns black. So it is conceivable that I could, there, I think I managed it right with that one. Yeah, there. So I can even get this to happen in between frames. There's no, so what? It's not a big problem.
Didn't understand it enough and thought that if you didn't do it properly and you just kept mashing, like let's say left, right, it means go right.
Yep.
That if you could press it enough times, if you loaded it wrong, your spaceship would like fly all the way across the screen without you even seeing it happen.
Yeah. So there's lots of things you have to control. So for example, even in this stupid game with the bubbles, there's some physics in there. When these two bubbles hit each other, they take off, you know, in some thing that's controlled by the laws of physics. And first time I implemented that, I wasn't thinking carefully, and I got it wrong. And I didn't. Ultimately, what I wasn't implementing was the law of conservation of energy. So these things basically would hit each other, and then they would be going slightly faster than before, and then slightly faster. And so every time there was a collision, these things kept going faster, and eventually they just shoot off the screen. So yeah, you have to be careful. I mean, it is possible to make mistakes that cause things to just totally disappear, and you've got to be careful. Okay. So for example, rather than relying on the user to click the window to quit, another common thing, especially if you're going to make the game full screen, which it's possible to do using PyGame, is to allow a keystroke for quitting. And so, for example, we could also quit if, let's say, or event.type equals PyGame.key down, but not just any key, and event.key is equal to key escape. Okay, so let's get the logic right. If the user, if we receive a quit event from the windowing system because somebody closed the window, we should quit. Or if the user pressed a key and that key is the escape key, then we should quit. So now the escape key also takes us out of the game. Okay, so there's a key down event, but these events also have other properties. You could see them when you print them out. You can see what the properties are. So for example, some of these mouse events tell you which buttons of the mouse are currently pressed, which position the mouse is at, and so on. And the key events have a property, the key down events have a property called key, and there's a whole list of these key codes that tell you these things. Yeah?
So is this how you would do key binding for Python, or is there like library for that?
Key binding in what sense?
Like mapping your own key sequences to do specific things in your program?
Yeah, I mean, PyGame is probably a lot to use if that's all you want to do. I think probably even most of the things that have an interface to the window manager should also be able to do that sort of key binding. Okay. All right. So in PyGame, most things are surfaces. So there are these things called surfaces. And this screen, which is the thing you get when you set the mode on the display, that's a surface. It just happens to have two sides that has 640 by 480 pixels. So surface is a rectangle containing some pixels. And usually when you create something, you get a surface. So let's try and make this thing do something a little simple, like display an image. Well, the first thing you'll realize is you have to know what you're doing in terms of what kind of images you want to use. So most images that you have are not suitable for use in games, and it's not because they're pornographic. It's just because they'll look bad when you try and draw them. So I'll show you a trick that will help you get some useful art for your games without having to create it yourself. So what you want is Google Advanced Image Search. So not just normal image search, but advanced image search. And there's two things that I'm interested in. I'm interested in, well, the license. I don't want to use some game or some image that people don't want me to use. So I'll pick things that are free to use or share. But even then, you should be careful when you actually take it. Really try and look and see what the user actually intended. But the really important thing is to make sure I get images with transparency in them. Because think about this little bubble game. There's these bubbles floating around the screen, and you can see through them. Well, the way that that's implemented is that bubble is an image. That image is a square shape, and it has some white parts to it, and then the rest of the image is completely transparent or partially transparent. And so that's why you can see through the image, and you don't see this square around the bubble floating around. So you really want to use these transparent images. And so what should we look for images of? This is a dangerous question. Cats.
Or the internet, so cats.
Funny cat pictures, yeah. Of course, you find some unusual stuff. So here's some cats, warrior cats. So this is not actually a transparent image, so there's not much transparency in it. The transparency ones you can recognize because they have this Google image search displays them with this checkerboard pattern. That means that part of the image is see-through. So let's grab this one. JPEG and PNG are the two that you'll use most often. So let's save this image, and I want to save it into HTML. Today is October 18th. And we'll just call it cats.png. Okay. So, so we'd like to draw these cats. All right, so we want to do that in our draw function. So PyGame has an image module. So I'm not just making these, just guessing these things, right? I found these things out. You know, when I want to know how to display an image in PyGame, I Googled PyGame image, and you get some code sample. And when I wanted to know what the key code was for escape, I said, you know, PyGame key codes and so on. So I want to load an image, and it was called cats.png. Okay. So that loads an image, and an image is one of these surfaces, which is a rectangle. Okay. So it's not drawn anywhere yet. It's just sitting off in memory somewhere. So I'd like to know how big this rectangle is. Or I'd like to know some stuff about this rectangle. So I'd like to inspect it. Let's try that. Just so we can, we're not going to display it yet. We just want to look at that rectangle. So it's a pretty big image, 648 by 411. It's almost as big as our window. So maybe we'll make our window a bit bigger. And now you see why comments quickly become out of date. So stupid comment anyway, so we'll get rid of it. So this cat is it's sitting. It's drawn in this image is a rectangle that's 648 pixels wide and 411 pixels tall. Now I want to draw this on my screen, and so the way you do that is you use an operation called a blit. So a blit is when you take one surface and throw it really fast onto the other one. It's called a blit because it happens so fast. So we have the screen, that's our target. We want to draw this thing on the screen, and we have this image. And we have to tell, we have to say where we want this to go. So for now, we'll say we want this to go on the rectangle that's provided. So the rectangle that is at positions 0, 0, 648, 411. So let's see what that does for us. So there's our cat cat picture that's drawn. If we go back and look at it in our web browser, so the web browser is basically drawing this thing in its rectangle. The actual image is rectangular in shape. That's it there. And so it's being drawn in our application basically with its top left corner up in the top left here. Okay. And so if I, where did it go? Yeah. I think that's it. Just there. So if I change the background color, notice the image that doesn't, it just works, right? So the image is actually this big rectangle, but parts of that rectangle are see-through, so when I change So this Windows and in computer graphics almost always work this way, and it's a little bit unfortunate, but it is. Do this. If I take that rectangle and I move it 100 units along the x-axis and 0 units along the y-axis, then the image moves off to the right, my right. Well, on there it's your right, on here it's my right. So the image moves off to the right. If I go the other way around, no x units, but 100 y units, then the image is translated down. So it stays off to the left, but moves downwards. Okay? So you have to get used to working in these coordinate systems. What if we would like to have this image centered?
Other layouts?
Nope. It's really raw. You're just given this canvas, you draw on it.
Divided by 2? Like divided by 2?
Okay, so the suggestion is centering it, we should be able to get it by translating to the width divided by 2. Yep. Okay, so let's take a look at what the problem is. So width and height were these two variables we saved at the beginning. So self.width divided by 2 and self.height divided by 2. So there, the image is centered, sort of.
Well, the corner of it is.
The corner of it is. So the top left corner of this image is right in the center of that window. Unfortunately, the image is completely under to the right of the top left corner. So if we want this to work, we can think of doing it this way.
Does this subtract half with the feature?
Yep. So here is some what is going to be some sad news to some of you, is that computer graphics requires computer graphics. This is a really simple thing, centering. So essentially what we did here was placed the image, or thought about placing the image down here, because what often happens, especially in this sort of game design, is you realize that image that you picked for your cat was a bad image. You don't like the way it looks, so you decided to switch to another one. Now the size of that image changed, so whatever numbers were in your program now don't work anymore. It's much better if you just take the values that you have for whatever image you happen to load and do the calculation. Because to compute those numbers, you would have to do that calculation anyway, unless you're doing it by trying numbers which are a little bit smaller and a little bit bigger until it looks just right. But why bother? So one thing that you can't see but I can see is this is a little bit laggy now. So when I press a key, it's now taking a little bit of time for the color to change and change back. You can't see that because you're not here pressing the key. And this is not a big, well, maybe we can even JPEG that's killing us, but Python is using a fair bit of the CPU here, 67%. And it shouldn't take that much to display a static image. Okay, so that's a lot better again. And you can even check that now even see Python as one of the top CPU users, so it's using almost nothing. So let's see. Yeah, well, it's still 32%. It's a bit, but it's not terrible. It's not using as much as it possibly can. Now it's actually getting a break between frames. Okay, so now you know how to load an image and blit it somewhere. What else do you want to know? Animations? Sure, animation. Okay. All right. So, what would we like to do to these two cats? Spin them. Okay. Someone said spin them. So, so spinning means rotating, right? And so that means we want to somehow take the cats and keep turning them, and that means we need to keep track of some angle or something. So basically, you know, what their current rotation is. So self.catAngle will start at 0. Now, so there is a function called, so there's a whole thing in PyGame called transform. So let's say pygame.transform.rotate. You give it the thing you want to rotate, that's the cat image, and you give it the angle that you want to rotate it by. Cat image, cat angle. Okay. And I think that's the right syntax. Let me check here. Yeah. All right, and that gives you back a new image. So let's call that IMG. So it takes the cat image, rotates it, and gives you back a new image. So this new image is not necessarily even the same size as the other one, because images are always these rectangles, and if you take a rectangle and rotate it, well, now if you want to cover it with another rectangle whose sides are horizontal and vertical, you actually need a bigger one than you started with, because the tops and bottom kind of sticks out. So you get back something that's not necessarily even of the same size. So now we'll work with that image we got back, and that's the thing we want to blit. Okay, is this going to work? No, not that. Will this work? So it says it has no attribute name move. So that didn't work because we just did the wrong thing. So there it's working. In the sense that that it obtains by rotating the other image by angle, and draw that new image. We set 0 and then we never changed it. So how fast do we want our cat to rotate? One could say what I could allow for them to make okay. If it's going to rotate, in instance, how many frames? So that's 50 frames that rotate. So I'll so there they go. We can try and time it. About 15 seconds. Okay, so a lot of this animation stuff is really about solving these little kinds of calculation problems, and so doing that kind of stuff. All right, what else would you like to know how to do? Yep. Collision. What do you want to collide? It depends. The cat and the walls. Okay, so so we're going to forget about rotating the cat? Okay, so you want to keep rotating the cat. So there's one problem here is we don't actually know how big the cats are because they're drawn on an image which has all this extra padding around it, so they won't actually bump into the walls. If we wanted to, we could use an image editor to go and edit that image, but we won't do that right now. But let's see if we can find an image that is useful for that. This is perhaps a dangerous search. Okay, good. Good, good. So, there we go. Yeah. It's a really big one. Is there any smaller ones? There's a better one, maybe. All.png. Okay. So we want to use that image, so we'll have to load it. Self.vol image equals pygame.image.load vol.png. All right, it's in the right directory. And So you say you want to do collision detection, which means it should be moving. So let's move this thing, and let's move it in some direction. So let's say the ball direction will be 1, 1. Okay. And where should we start the ball? We'll start it 0, 0. Okay. So like the cat, we want to, we have this ball that we want to draw. So we'll say this is our cat drawing stuff. Now let's do our ball drawing stuff. So there we want rectangle equals ball image rectangle. We would like to move that rectangle so that it's moved to the current position of the ball. That's ball image ball position at 0, ball position at 1. So we move it to the current position, and then we blit it. Okay, so just make sure that we're drawing this thing. Okay, so we're drawing this thing correctly, and now we're supposed to, it's not moving yet because we haven't changed its position ever. We set it at 0, 0, so the top left corner of the image is at 0, 0. And so now we want to do the moving. So how do we make the ball move? So we want to change its position, and its position has a particular direction. So we'll say self.ball position equals self.ball position at 0 plus direction at 0. Right? So it's supposed to be moving along this vector, ball position at 0, or ball direction at 0, ball direction at 1. Right now that vector is set to 1, 1, and so that's what we'll do. So let's see if that works. There you go. So now the ball is moving at that way. Now that's a little bit too slow, so a couple of ways we can fix that. We can just define a variable called speed. And let's make the speed, I don't know, 8. And that vector that we're moving along, we'll multiply it by speed. So now instead of moving by 1, 1, it'll move by 8, 8. So that's faster. And there it goes. All right, so you wanted to do collision detection. So what kind of collision just happened there? Or what kind of collision should have happened?
The bottom right corner of the ball should have hit the bottom bar, so the maximum length of.
So the bottom of the ball should have hit the bottom of the screen, right? Okay. So let's see if we can make that work. So if rectangle.bottom is bigger than self.height, that means the bottom went off the bottom of the screen. What should we do then?
Change direction so that y is now negative.
So we change the ball direction so that it bounces off, and we'll have that be self.ball direction at 0. So it should still, if it was going left to right and it hit the bottom of the screen, it should still be going left to right. So the x direction doesn't change. But the y direction, if it was going down, it should now be going up. So we should fix that at 1. So let's see if that works. Bonk. Oh, there it goes. What happened there? Yeah, so we took care of the bottom side. Now we need to do the other 3 sides. So going off to the right, that's if the rectangle's right side is bigger than self.width. So if we hit the right wall, what do we change? What happens to the direction of the ball?
Goes left.
Yeah.
Negative x.
So its x component gets reversed. Instead of going to the right, it should now go back to the left, but that doesn't change its y component. And we have to do the top. So that would be if rectangle.top is smaller than 0, because 0 is the top of our window, then that's a change in the y component. And if the rectangle's left is smaller than 0, we want a change in the x component.